Hello, welcome to our lesson on synthetic division. Now, if you watched the last video on polynomial division, you'll, most people leave that being like, that's a lot. I don't want to do that every time, and neither do mathematicians. So they came up with this thing called synthetic division, which is much quicker. So for instance, if I have this polynomial and I know it has a root at 2, what I do is typically they set up a framework where they put the 2 over here, they put the coefficients for the polynomial here, and now the first value we just drop straight down. So this one has a method. First thing we do is drop. Then we multiply. 2 times 1 is 2. Then we add 7. Then we multiply. Um, so that's 14. That gets us to 12. Then we multiply. 24. That gets us to nothing. So this would have been the remainder if there was would have been something. But now this, we go back 1 degree. And so this is x squared plus 7x plus 12. And since the 0 is 2, that would be x minus 2. So these two multiplied together are going to be equal to x to the third plus 5x squared minus 2x minus 24. Now let's take this a step further. If I can factor this, x plus 4x plus 3, because they multiply to 12 and add up to 7, now I have a nice little equation. And if I want to find the graph of this polynomial, I know it has a 0 at -4. It has a 0 at -3. It has a 0 at 2. And it's positive leading coefficient, so it's a positive x cubed. So that means it's going to kind of go in this direction. So our polynomial in general kind of looks like this. I guess we know one other piece of information. Its y-axis hits at -24. That's not an equivalent scale, but that's good enough for a quick sketch. So we generally know what that function looks like. All right, let's try another one. So we have this polynomial, and we are told that 1, 0 is at 5. So I'm going to write in 1, -7, 2, and 40. The first thing we do is drop it down. This goes down to -2, -8, -40. So now I have x minus 5 times x squared minus 2x minus 8. Now, if I wanted to graph that out, this would be -4 plus 2. And we have a zeros at 5, 4, and -2. And it has that positive leading coefficient. Let's see what this says. Yeah, I think that's what I just did. Great. Now, this one, if you were in class, I'd have you try this one on your own. But one thing I wanted to state is this synthetic division works really well if you have a 0 that's a 3. It doesn't work quite as well if our 0 is a fraction. There are ways to do it, but it just kind of messes things up and gets confusing. So if we have a term that's like 3x minus 1 in a polynomial, typically we leave that in there and factor that out at the very end, or use quadratic formula to find that term. So if we do this one real quick, 1, 3, 0, 0, -9, -27. And so it would be x squared minus 9. And this one, of course, would be x plus 3x minus 3. And then we have another one, x minus 3. So that would be x minus 3 squared, x plus 3. All right. Now, if it's a bigger one like this, and they tell you there's a 0 at -2 and 3. So 1, -4, -13, 28, and 60. So that would be 1, -2, -6, 12, -1, 2, 30, -60, and that's done. So we know this divides evenly into it. So now what we have is x to the third minus 6x squared minus x plus 30. Now if I want to factor this as far as I can, I want to take this, our result from our first one, and put it up here. So that would be 1, -6, -1, and 30. Now when I do this, now that cancels out, and I have to write our answer in factor form. First, I'm just going to minus 3x minus 10, and now this would be an x minus 3. This one would give us an x plus 2, and that looks great. To totally put it in factored form, we would want to factor this, which would be an x minus 5, x plus 2. Now since there's two x plus 2's, we say this is x plus 2 squared. Another way of talking about it is we'll say this is has uh, a 0 at -2 with a multiplicity of 2. So if you hear the word multiplicity, that just means it has two zeros, which that means graphically it's going to touch that at that point and turn around. So we have a 0 at 5, at 3, and at -2. Now, positive leading coefficient, so it's going to look like uh, a parabola. Generally, it's going to come down, it's going to hit here, and that double zero tells us that it's going to turn around, and then it's going to come back through and hit at those 2 points, and then keep going up. Now, this isn't exactly what it looks like. Just based off the information we have, it's a general graph of our function. All right, I think from there you should be able to figure things out on your own. Good luck. Good luck.